modern theories regarding the origin of the universe. The most popular argument regarding the origin of the universe is the Big Bang theory. Big Bang theory is the most widely accepted theory regarding the origin of the universe. Edwin Hubble, it is also called the expanding universe hypothesis. Edwin Hubble in 1920 provided evidence that the universe is expanding. See, the Big Bang theory is also known as the expanding universe hypothesis. This is Edwin Hubble, and in 1920 he provided the evidence that the universe is expanding. He is Edwin Hubble. He is the same person after whom the Hubble telescope is named. See what happened, that around 13.7 billion years ago there was an explosion of what? A very small, extremely small hot bubble. All right, and this point was known as this bubble, or this point was known as the point of singularity. It exploded. This point, it exploded, and hence the universe was born. Time, space, matter, it all began with the Big Bang. Now let us see what is a first of all, what is a point of singularity? It is also known as the singular atom. See, it is a very tiny ball. You can call it as a dot, or a very tiny bubble, or a tiny ball, or a singular atom. And it has a very, very, very extremely small volume. You can see it's only a point of infinite temperature and infinite density. Galaxies move further and further apart. You can experiment and find what does the expanding universe mean. Take a balloon and mark some points on it to represent the galaxies. Now, if you start inflating the balloon, the points marked on the balloon will appear to be moving away from each other as the balloon expands. Similarly, the distance between the galaxies is also found to be increasing, and thereby the universe is considered to be expanding. So we know that the universe, it grew from a single atom to bigger than a galaxy, and we know that it is still expanding. So the experiment is all about that we have to take a balloon and mark some points on it, and these points will be representing the galaxies. Now we have to inflate the balloon. So what do we observe now? That the points marked on the balloon, they tend to move away from each other as the balloon expands. Similarly, the distance between the galaxies is also increasing, in which the points marked on the balloon are expanding. So hence we conclude that the universe is still expanding. Next, however, you will find that besides the increase in distances between the points on the balloons, the points themselves are expanding. Also, we can see that the points which we have marked on the balloon, they are also increasing. The distance between the marks are increasing. Also, the points which are, they are themselves also increasing. But it is not in accordance with the fact. Scientists believe that though the space between the galaxies is increasing, observations do not support the expansion of galaxies. All right. The distance between, what is the conclusion? The distance between the galaxies are increasing, and the galaxies are not themselves increasing. The size of the galaxies is not increasing, as we can see in the experiment of the balloon. The Big Bang theory considers the following stages in the development of the universe. Number 1. In the beginning, all the matter forming the universe existed in one place, in the form of a tiny ball, or a singular atom, with an unimaginably small volume, infinite temperature, and infinite density. See, we know that everything evolved from a single point, or a tiny ball, or we can call it a very small hot bubble. And this point is known as the point of singularity, or we can also call it as a singular atom. And what is it? It is a single atom with a very extremely small volume, infinite temperature and infinite density. Then the next point, at the Big Bang, tiny ball exploded violently. This led to a huge expansion. It is now generally accepted that the event of the Big Bang took place 13.7 billion years before the present. So, when did the Big Bang took place? It was about 13.77 billion years ago. The expansion continues even to the present day. As it grew, some energy was converted into matter. There was particularly rapid expansion within fractions of a second after the Big Bang. Thereafter, the expansion has slowed down. Within the first 3 minutes from the Big Bang event, the first atom began to form. After the Big Bang event took place around 13.7 billion years ago, in just fraction of seconds after the explosion, the universe, it grew from smaller than an atom to larger than a galaxy. You can see in the picture. And it continued to expand. You can see it continued to expand, and it is still expanding today. So in the first second, the universe has grown around to 100 billion kilometers. Then, after the Big Bang, the universe started to cool down. Gradually, the universe started to cool down. The energy which was released, it got converted into some particles of matter and antimatter. Now, these two opposite particles, they largely destroyed each other, but still some of the matter, it managed to survive. So we have already seen that the universe has grown around 100 billion kilometers. So now it was cold enough. The universe was cold enough to form more stable particles. More stable particles called the protons and the neutrons. In the next 3 minutes, and what happened after the Big Bang? In the next 3 minutes of the Big Bang, the temperature fell down. The temperature fell below 1 billion degrees Celsius. So now there was a even further reduction in the temperature of the universe, and now the universe was cold enough to allow the protons and neutrons to form its first atom called the hydrogen. After millions of years, the hydrogen atoms, they clumped together, and the gravity started to pull it, and hence it led to the formation of the stars, galaxies. After the stars and the galaxies began to form, their radiation began to dissolve the hydrogen gas into what? Into plasma. Plasma is a state of matter. So what happened that the hydrogen gas, it started to dissolve and ionize, and it got converted into plasma. And this state of matter called the plasma, it allowed the visible light to pass through it, and finally there was light in the universe. So within 3 lakh years from the Big Bang, temperature dropped to 4500 Kelvin and gave rise to atomic matter. The universe became transparent. Actually, what happens that hydrogen is a very highly combustible gas. What is the meaning of combustible? It means that it catches fire very easily. So when the hydrogen is introduced to a low pressure system, the hydrogen atom disassociates, or it breaks association, and it also ionizes. What is the meaning of ionizing? See, ionizing is the process in which the atom or the molecule, it acquires a positive or negative charge by what? By losing or gaining electrons. So the hydrogen, when it is introduced to a low pressure system, the hydrogen atom, it disassociates or and it ionizes as well, while changing its phase from gaseous to plasma. After millions of years, after the hydrogen clumped together and gravity started to pull it under pressure, now the stars and the galaxies started to form. Then what happened? Their radiation, it began to dissolve the hydrogen gas into what? Into plasma. As you can see in the picture, that that hydrogen gas was changed into the fourth state of matter. We know that the fourth state of matter is the plasma. And now this plasma, it allowed the visible light to pass through it. And finally there was light in the universe. Let me just summarize that plasma is called the fourth state of matter, as you can see in the picture, apart from the three states of matter like solid, liquid and gas.